All right, so as promised, back with a second video. This time, we're going to focus on the area of a parallelogram. Um, Typically, when we're finding the area of a polygon, our base and our height, our length and our width need to be perpendicular to each other. That's why it's really easy to find the areas of squares and rectangles because all the sides are perpendicular to each other, making it really convenient to figure out where the base and the height are located. When it comes to parallelograms, that's not always the case. So, squares and rectangles are specific types of parallelograms, but not all parallelograms have perpendicular sides. So, what we need to figure out is how do we actually determine the area of a parallelogram then if our base and height are not perpendicular to each other. So, let's kind of just draw a random parallelogram, at least the best that we can. All right, so here's a parallelogram, and actually I'm going to redraw that. Let's try that again. All right, so there we go. That's a little bit better. Okay, so I mean, clearly here the sides are not perpendicular to each other. So how do we determine, where the base is located, where the height is located if those sides aren't perpendicular? So here's kind of the trick that we're going to use. All right, so basically what I'm going to do here is I'm just going to pick this vertex that I've highlighted in black, and what I'm going to do is I'm going to drop in a perpendicular line. Now, what you should notice here is that I'll highlight this for you. We've created a right triangle. Now, the cool thing is that we can then kind of shift this triangle over here. So I'm going to drop that in like this. And that triangle actually fills in the parallelogram perfectly. And what it does is it creates a rectangle. So, where are our base and height? Well, that perpendicular segment that we dropped in will be the height of our parallelogram. And then the base will just be the length of the side that it's perpendicular to. So this would be our base. All right, so the key is we're going to have to drop in a perpendicular in order to make this work. So here is the theorem written out formally for us. Now, the base can be any side, and the altitude is any segment that's perpendicular to the line containing a base from any point on the opposite side. So we'll go through and we'll do some examples here. We'll do two examples, and I think you should probably get the idea once we've done that out. So let's take a look at example number one. Reads find the area of a parallelogram with base 5 root 3 and corresponding height 4 root 3. So for this one, I'm definitely going to draw a diagram just so you get a feel for what we're talking about here. So as we mentioned, the base and the height have to be perpendicular. So what I'm going to do is I'm going to drop in an altitude. And that altitude is going to be our height, which is 4 root 3. And the base is just the side that height is perpendicular to. So to find the area, very straightforward. We're just multiplying the base times the height. So the base is 5 root 3. The height is 4 root 3. So we'll do this in our head. 5 times 4 is 20. Root 3 times root 3 is 3. So the area of this parallelogram, is 60 square units because, again, the units are not specified. All right, pretty straightforward there. That was pretty easy because both the lengths of the base and the height were given to us. I just drew the diagram so you could kind of get a feel for the fact that the base and the height have to be perpendicular to each other. Now, example number two says find the area of the parallelogram shown. This one's, a little bit more work because here we don't know the specific value of the height. But the good thing is that we can use our knowledge of, in this case, in particular, 30, 60, 90 triangles to help us out. And if we didn't have that, we could probably use, We could definitely use right triangle trig to help us out here, or maybe even the Pythagorean theorem, depending upon the information that we're given. So this triangle that I outlined in black is a 30, 60, 90 triangle, and the height is the short leg of that 30, 60, 90 triangle because it's opposite the 30-degree angle. So that has to be half of the length of the hypotenuse. So half of the length of that side. So that means that the height is equal to 4. Now our base is going to be 12 because the height is perpendicular to that, to this side right here that I've highlighted in red, and the opposite sides of a parallelogram are equal. So the base is 12. So to find our area, we're multiplying the base times the height, which is 12 times 4, and that gives us an area of 48 square units. All right, so that was just a quick one to show you the formula for finding the area of a parallelogram. You just really need to make sure that the base and the height are perpendicular to each other before you go and try and find the area. Okay. If you have any questions or concerns, make sure that you email me or message me through Google Classroom. Otherwise, good luck, and we will see you in the next video.